All right, let's learn about speed and velocity in terms of scalar and vector quantities. We'll be learning definitions of them, key differences between them, and we'll also be able to understand their significance in physics, learn the formulas for each of them, solve problems, and recognize how the direction of motion affects velocity but not speed. Okay. To begin with the definitions, speed is a scalar quantity. It is the change in distance per unit time. Okay. Let's say a car is moving at a speed of 60 kilometers per hour. You only talk about the speed of it, 60 kilometers per hour. That means the car is covering 60 kilometers every hour. Okay, so the distance that the car is covering per unit time is the speed of it. Okay, on the other hand, velocity is the change in displacement per unit time. So displacement is related to the direction and value. That means velocity will also be a vector quantity because of this. Okay, you'll also have to notice that a train moves at 60 kilometers per hour towards Dhaka. Let's say this direction is Dhaka. If it is moving backward to the opposite direction, we would be writing negative 60 kilometers per hour. Okay, so if you specify any direction to be positive, the opposite direction should be negative value. Okay, since direction is also attached to this quantity, you'll have to learn that opposite direction, the value may remain same. In the opposite direction, it will be a negative value. All right, let's have a look at a comparison table to compare speed and velocity. Many a time you'll be asked to write the differences between speed and velocity. So you'll have to write definition, unit symbol, equation, all of this. Okay. The symbol of speed can be of two kinds, U or V. U is used for initial velocity. Initial means in the starting. Let's say a car speeds up from 20 kilometers per hour to 30 kilometers per hour. Okay, so initial speed here is U, 20 kilometers per hour, and this is the final speed, V. Final speed is represented by V. Similarly, in velocity, they have the same symbol, but for U, we say this is initial velocity and V is the final velocity. Okay, they have the same SI unit, standard unit, meter per second. Okay, distance covered per unit time, so meter per second. This also has the same unit, meter per second. Okay, unit symbol is the short form of it, m/s, so meter per second. This is also meter per second. Okay, quantity, as we know, speed only has value, so this is scalar quantity. Velocity has value and direction, so it's a vector quantity. Okay, equation, we learned in the previous lesson that d equals to vt in a samosa like this. Okay, so distance equal to speed multiplied by time. If you hide speed here, you'll see that this is distance over time. So v equals to d over t, distance by time. Okay, in the case of velocity, we will be writing v equals to s over t. Okay, because velocity is related to displacement, not distance. Okay, let's have a look at an example. It says if an object travels 200 meters, 200 meters is the distance, in 40 seconds time. So distance and time given, you can easily calculate speed. Speed equals to distance over time. So 200 divided by 40, you get 5 meter per second. Okay. In the case of displacement, let's say the displacement is 180 meters and the time remains same, 40 seconds. So velocity is displacement over time, 180 displacement over 40 seconds. If you calculate this, you'll get 4.5 meter per second. There can be similar questions in the exam where any two values will be given, you'll have to find the other one. Let's say d equals to vt. If speed and time given, you'll have to calculate distance. If distance and time given, you'll have to calculate velocity. Similarly, if time is given, you'll have to calculate the time. To recapitulate, we have covered definitions and formulas of speed and velocity. We learned that speed is scalar quantity, it only represents value, and velocity represents a vector quantity, so it has value and direction. We also learned that in the opposite direction of the first one, we will always write negative sign. Okay, so we understood scalar and vector differences in this context, and we compared both using a table and an example. Thank you.